Hey everyone, ever wonder how robots really understand the world around them? Like how do they know where to put that cup or figure out the best way to clean a room? Well, today we're diving into a breakthrough in AI called RoboBrain 2.0, a system designed to help robots think and act more like humans in real-world environments. Let's break it down. Even though AI has come a long way, robots still face three critical challenges. First, spatial understanding. They struggle to grasp relative positions, like distinguishing left from right. Second, temporal modeling. They often can't plan ahead or adapt when things go wrong, like adjusting if a vacuum gets stuck. Finally, reasoning chains. They have trouble connecting cause and effect, like following a multi-step instruction. Move the red block to the blue box after turning off the light. That's where RoboBrain 2 comes in. Think of it as the ultimate brain for robots, combining vision, language, and planning into one system. It's like giving a robot the ability to see, understand instructions, and think through problems, all at the same time. How does it work? RoboBrain 2 uses two main components: a vision encoder to process images, and a language model to parse instructions. But here's the twist. It's trained on massive datasets, including synthetic data for spatial tasks, like predicting object positions and multi-robot simulations for temporal planning. For complex reasoning, it even learns from thought processes of other AI models to grasp cause and effect logic. The results? RoboBrain 2 outperforms previous models. It predicts spatial relationships, plans multi-step actions, and adapts when obstacles arise. And it's not one size fits all, two versions exist. The 7B model handles simpler tasks, while the 32B version tackles complex environments. But here's what excites researchers: it's open source. Anyone can use it. Imagine a robot that doesn't just follow orders. It understands its world, plans like a human, and adapts in real time. That's the future being built by systems like RoboBrain 2, a breakthrough in embodied AI. Today, we're unpacking how this technology is rewriting the rules of robot intelligence, outperforming even the most advanced models in critical tasks. Let's dive in. So what makes RoboBrain 2 special? It's a hybrid system that combines vision, reasoning, and planning. Think of it as a robot's brain that processes images, understands spatial relationships, and makes decisions, like a human would. But how do we measure if a robot is smart? Enter the Share Robot Trajectory Test. This benchmark evaluates navigation and motion prediction using dynamic Freight distance, DFD, a metric where lower numbers mean smoother paths. RoboBrain 32B scores 0.2368, crushing competitors like GPT-4o, 0.5726, and Gemini, 0.7666. Even the 7B version hits 0.5512, proving it's no slouch in path planning. But navigation is just the start. RoboBrain 2 shines in temporal reasoning, understanding sequences, predicting future actions, and coordinating multiple robots. Let's break down three key tests. 1. Multi-robot planning. In a supermarket, robots stock shelves without colliding. RoboBrain 32B scores 80.33 average, with task scores over 84%, outperforming giants like GPT-4o and QN2, 5VL72B. The 7B version matches top models in some scenarios. 2. EgoPlan 2. This test measures daily task planning, like cooking or organizing. RoboBrain 32B scores 57.23, far ahead of competitors. The 7B version still beats specialized systems like VBrain 8B and Cosmos Reason 17B. 3. RoboBench. Here, robots handle complex manipulation tasks, like picking up objects from different angles. The 7B version claims the top spot with 72.16, outperforming models like Claude Sonnet 4 and GPT-o4 Mini. The 32B version isn't far behind, scoring 68.33, a testament to its versatility. What makes RoboBrain 2 so powerful? It's not just size, it's a modular architecture. Think of it as a team of specialists: a vision encoder for high-res images, a language model for instructions, and a planner for step-by-step logic. This design allows it to handle both simple and complex tasks efficiently. Imagine this: a robot is told, find a muffin cup and pour coffee into it. Sounds simple, right? But here's the twist: it's not a straight line. The robot must navigate a room, hunt for the mug, figure out how to work the coffee machine, and adapt if things go sideways. If the button's sticky or the cup's not where it expected, RoboBrain 2 doesn't panic. It learns from feedback, tweaks its plan, and tries again. It's like a chef tasting a dish and adjusting the seasoning. Each step gets closer to perfection. But how does RoboBrain 2 even understand all this? It's not just following rules, it's reasoning. Think of it like solving a puzzle with shifting pieces. The system uses synthetic benchmarks, training drills to test its skills. One challenge might ask, which object is closer to the camera, while another counts chairs in a room. These tests push the robot to process visual clues, spatial relationships, and abstract concepts like reachability. What makes this possible? A combo of actionable affordance areas, the purple boxes you might have seen, and deep learning. These areas highlight where actions can happen, like where to place a pan or how to grip a cup. The robot uses this to make split-second decisions, adapting as things change. It's like having a GPS for movement, but way more dynamic. So RoboBrain 2 isn't just following instructions, it's thinking through them. Whether it's navigating a cluttered kitchen or planning a multi-step task, it's rewriting the rules of how robots interact with our world. And here's the kicker, this is just the beginning. What do you think? Ready to see robots become smarter than ever? Let me know in the comments. Maybe we'll explore how these systems could help in your own home next. Stay curious, and let's keep unlocking the future of AI together.